First things first, sometimes you guys watch the Delta Math help videos, which you should, but I would caution you today not to, just because the video is filmed, made with the assumption that you have a TI something graphing calculator, which is not the case. There are lots of us that I think out of my Algebra 2 kits, I probably have 10 or 8 that own those, and then I got another 20, 24 that don't. And so for you to watch that video, you're going to see Zach, the guy that does the video, talking about plugging the function into your calculator and trace features and tables, things that your $12 scientific calculator just can't do. So just kind of be advised that if you go to watch one of the videos, it's not going to really end well. I don't even quite frankly think it's going to help you one iota, because we're going to do everything from a different sort of perspective. I will teach this from the perspective of we have TI 30s and $14 Casios and stuff like that. So anyways, the lesson I really, I mean, I'll start the lesson with Delta Math. I think my plan is just to go through Delta Math problems with you, so that you can see what we're up against. There's some different flavors of problems, and so I don't know if I'll hit them all. I might try, but time will be an issue here. So we're going to be dealing now with word problems that have to do with quadratics. So go ahead and take a moment and read that. And don't worry about like copying it down. I would say just try to maybe get the pertinent information out. But I know that's probably hard to read. I'll try to zoom in a couple of times. We're going to be looking at this equation in more detail within the next day or two. It's a common gravity equation. So this is one of the most common applications of quadratic equations. Let me see if I can get a little bit. Does that help? Oh, yeah. Much better. So this is an equation that represents or relates the height of something like a projectile, a rocket, something like that. It relates that height with time. And you'll see these variables change throughout the next few days. Y will be replaced sometimes with H for height. X will be replaced with T for time. So just kind of be aware of that. But this today was just intended to be sort of our introduction into just the mechanics of sort of how this works. So our goal is to figure out how high the rocket gets by looking at this equation. So if you were to model the flight of a rocket, what would it look like? What shape would it be? We know this shape. It would be a parabola, right? So anything generally that gets launched or thrown or projected upwards is going to go up, and then it's going to eventually come back down. And so that's why applications of quadratics are so common, is that parabolic motion, like if you throw a ball, it's going to take a motion like that. And so gravity plays on objects at a very predictable rate. Like gravity on Earth, as you know, maybe you know this from science, is negative 16 or 32 feet per second squared. That's acceleration towards Earth. So gravity plays predictably, like it doesn't change if you're in like Europe or if you're in South America or something like that. So this number right here is going to be pretty common for the problems that we work. You'll get used to seeing it. You won't see it in all of today's problems, because some of today's problems involve things that aren't projectiles. Just FYI. Anyways, this is what the equation looks like. And so we're trying to find the maximum height reached by the rocket. We have a name for that. What would we call that height? Like we have a name. Here, I'll graph it again. Well, I'll graph it. It's called the vertex. Good job, you guys. So if the rocket takes a shape like this, if it flies like this, then clearly what the problem is asking us for is the vertex. We're looking for this point. And you'll be asked a couple of different questions in regards to the vertex. Now, one of them is how long does it take for the rocket or the whatever to reach its maximum height? And another question is, what is the maximum height? Well, this one says to find the maximum height. So are we looking for the x value or the y value? The y value. Good. You guys understand what's come out of my mouth so far. I'm impressed. Good job. So y is our variable that's like the quote unquote answer. That's the height of the rocket. And x, there's one here. See if I can get the right color. There's one here and there's one here. That is going to be the time. All right. So we have to play around with this. Now, thankfully, we have some pretty mad skills when it comes to finding the vertex. We're certainly not going to convert this into vertex form. That would be a bit nasty, I think. Under most circumstances, like trying to convert it is going to be a bit more work, I think, than it's worth. So we're interested in the vertex. What's our little happy formula that we used to use a week or two ago when we would go to find the vertex? Good recollection. That's what we're looking for. We're looking for negative b over 2a. So negative b over 2a is going to get us out of a lot of pickles. Negative b over 2a. That always allows us to find the x coordinate of a vertex of a parabola. Under any circumstances, that will work. So negative b over 2a, what's our a value in this case? Did I say a? Yes, I did, didn't I? So A is negative 16. Let me go to my skinny pen here for a second. So A is negative 16. And what's B? 228. Good. So using our calculators, we're going to type in the opposite of B, which is going to be negative 228. And we're going to divide it by double A. What's 2 times negative 16? Negative 32. Any little missed signs are going to cause us a lot of stress here. So be really, I've been harping on you since I met you a long time ago that signs are not to be taken lightly. So I don't need to type it into my calculator as a negative divided by a negative because duh, it's going to come out as a positive. So if I type in 228 divided by 32, I get 7.125. So that means that the vertex occurs at an x coordinate of 7.125. What does that mean in the context of this math problem? What does that number represent? It's really important to me as we navigate these that you understand the numbers, that they're not just numbers flying around on a paper. Good job. It means how many seconds after it's launched will it achieve its apex, its highest point. So that does not tell us the highest point. That tells us how long it takes. And there will be times throughout this assignment, occasionally it's randomized when it's going to ask you how long does it take to reach this highest point? Or in a different context, it might say, how many items do you have to sell to achieve a maximum profit? So in this case, I'm not really interested in the 7.125. That's not to say that I don't need it, because I do. But what am I going to do to find the actual maximum height? We're going to plug it in. Remember, that's an x value. And so we're going to plug 7.125 in right here. And we're going to plug it in right here. And you can do this all in just one fell swoop in your calculator. You can do it in pieces if you're more comfortable with that. But if you do just type it all in at once, it's going to say negative 16. And then you're going to do parentheses 7.125. You don't need time signs in a case like this. Parentheses will work just fine. And then we're going to square that. You don't have to hit enter. And then you're going to hit plus. If you do have an older calculator, like from the 80s, like an older TI-30, then you would need to be hitting enter probably a lot more often and then writing numbers down perhaps as you go. But a newer calculator, you can just type the whole command in one line, which is what makes them so nice. And then we're going to do plus 228 times 7.125 plus 110. I'm going to type that in real quick. So negative 16, open parenthesis, 7.125, close parenthesis, squared, plus 228, parenthesis, 7.125, close parenthesis, plus 110. And I'm going to get 922.25. So 922.25. So that number obviously represents the maximum height of the rocket. Now, I did put 3 attempts on all these problems today, just because I wanted to make sure that you've got your first miss might be an oopsie. And then your second miss might be it's time to call the teacher and see if I can get some help before I get the dreaded I can't go back and fix it. So 3 attempts means you get 2 freebies. Well, a common mistake here would be to type that in, right? So like if I typed in 922.25, why would it count it wrong? Because it says to the nearest tenth of a foot, correct. And so the nearest tenth, and that's going to change throughout the assignment. Make sure you know your decimals. The nearest tenth is 1 decimal place. So that means I'm going to round to this 2 that I've got underlined here. So what will I type in? 922.3. Very good. So I'm going to type in 922.3. I don't think you need like a label because it's already specified as to the nearest tenth of a foot. So 922.3 is the maximum height of the rocket. Got it? Okay, let me clear this and find a different type of problem. So let's see. Let's try this one. I got to be honest, this is roughly the same exact problem. So I didn't know what order these would come in today's lesson. So whether you believe it or not, it is identical. It's just not the same situation. So here's sort of a deep thought for you. If you had a company and you were going to sell items and you were going to gauge, was that a sneeze? Bless you. If you were going to graph or compare or relate the number of items that you sell to the profit that you make, the curve is going to generally go like this. Why is that? Like, let me ask you a question. Why on this side of the curve am I not maximizing my profit? X is what is it? How much I'm selling them for, and Y is how much profit I make. Why am I not making a max profit over on this side? Because it's too cheap. So I might be selling a lot of them, but I'm not making enough to maximize my profit, right? So yeah, I'm gonna sell a bunch, right? I might be taking something that I could be selling for more and selling it for $4. And of course, I'm gonna sell a buttload, but I'm not maximizing my intake. And why on this side am I not maximizing my profit? It's too expensive. And yeah, I do great when people buy them, but I don't sell a lot of them because I'm asking too much. So there's an optimal point right here. And of course, again, it's called the vertex. And so using mathematics, I can take and plug input values into a model. So like one way to do it, the way if you watch the video that Zach did it in the video is he just has you go through a table of values, which is really nice if you happen to have a TI-84 laying around. And then you can actually look at the Y values and then you can find the peak by just examination, but not us. Like, again, that's not the approach we're going to take. So for the second straight time, we are just going to go find the vertex. We're interested in the vertex. So we're going to do negative B over 2A, right? And again, I would be leery there. Like if I got a negative number there in the context of what we're talking about, I'd want to go back and say, why did that happen? Like I'm not going to charge a negative selling price. Like they would be getting paid to take my item, which is really dumb, right? So I'm going to type in 1280. Again, I'm going to ignore the negatives because why not? Divided by 54. And I'm going to get 23.7037. And this is an interesting sort of thing in that, and I'll go along with you here. I'll kind of learn along with you. The amount of accuracy that we need is going to be something that we'll probably just figure out here together. But for now, I look at it as, according to this, I need to sell my widgets for about $23 and change. And I'm going to go with 4 decimal places ought to be enough. So this is 23.7037. So the question is, if I sell my widgets for that much, what will my profit be? And that, of course, is going to come from finding the Y value of that vertex right there. So for the second straight time, we're going to go heavily into our calculators. And if you're not practicing this along with me, it's okay. But it is just the kind of thing you can just do all at once. So I'm going to type in I'll just call this like the green number here, so I don't have to write it all on the board. I'm going to do negative 27 times the green number squared plus 1,280 times the green number minus 7547. And if we get a red X on this, then we'll know that we just weren't accurate enough or precise enough with the decimal rounding that we elected to use. So negative 27, open parenthesis, 23.7037, close parenthesis, squared, plus 1280, open parenthesis, 23.7037, close parenthesis, minus 7547. What kind of an answer here would, before I hit enter, would make us think we did something wrong? A negative would, of course, not make any sense, right? So we wouldn't be optimizing our profit if I hit enter and I get a negative. And I got 7623.37. And it does say to round to the nearest whole dollar. There, you know what? You might be surprised. The very next problem after this might say round to the nearest cent, in which case my answer would be 7623.37. But in this case, it says to the nearest whole dollar. So what am I going to type in? 7623 is going to be the maximum profit. So 7623 is what I'll type in. I would imagine that's going to be enough precision, but let's find out here. So we're good there. And honestly, I never know as your teacher, what is the perfect amount of precision? My take is carry around as many decimal places as you can stomach. Because like if you go liberal, like on that X coordinate, if we'd rounded it to like 23.7, I'm concerned that at some point that lack of accuracy could have an impact that would affect our answer. So carry around a few decimal points, whatever, use your discretion. But if you know you're doing it right, but your answer is wrong, it's probably going to boil down to you didn't use enough decimal places. Sound good? All right, let me see if I can find another flavor of problem. So let's take a look at this. Again, familiar territory. And here's this number again. Anytime you see any sort of projectile problem, you're going to probably see this number. The only time that'll be different is if you're doing metrics. So if the heights are given in meters, then that number is going to be negative 9.8, I think it is. So because this is feet, so it depends which side of the pond maybe or which context. So anyways, this is the same situation. We've got a rocket. It's like a projectile kind of, and we follow the same model. But this time you'll notice it doesn't say to find the rocket's maximum height. These problems will be quicker. It's asking us to figure out the time at which the rocket will reach its max. At no point in this problem are we being asked to find the maximum height of the rocket, just how long it takes. So what are we really looking for here? Just the x. The x is the time, remember? And so if I just do my negative b over 2a, it's game over. These are a lot quicker, a lot less annoying, perhaps. So we're going to do negative b over 2a. And again, I will just omit the negatives because I wasn't born yesterday. I'm going to type in 145 divided by 32, and I get 4.53125. And then I'm going to read the directions. And it says to the nearest hundredth of a second. How many decimal places is that? 2. So far today, we've seen a whole number. We've seen a tenth. We've seen a hundredth now. So what would this be rounded to 2 places? 4.53 is correct. So we could then say that at 4.53 seconds, the rocket would be at its apex, right? So let me just find, I think there's only one more variety of problems that I just want to scour and find one for you just to make this complete. Not another, I think that's, oh wait, I want to, let's see. Oh, there it was. Darn it, I missed it. There it is. All right. So this will be, I think, the last one. And if you encounter any flavors that don't match, by the way, like you might see a profit problem that says how much do the widgets have to sell for. That's just like the one we just did. You're just looking for X in that case. So, but this is a unique situation. So again, we see the old familiar negative 16. It's the old gravitational sort of constant here. And we're being asked this time, how long will it take before the rocket hits the ground? Interesting. So I'm not interested in the vertex. This is the only problem so far in the notes where the vertex hasn't really mattered. I'm not interested. I'm interested in what? When the rocket hits the ground. So if you model the rocket's flight like this, we're interested in this point right here, kapow, when the rocket smashes into the ground. And what does that mean for us? Like in the context of math, what does that mean we do? What's the height when the rocket hits the ground? Good. So these types of problems, you're going to replace the height with the number 0. And we are, of course, going to liberally for this use the quadratic formula. So we're solving an equation, so that's going to enable us to bust out the quadratic formula. Okay, thank you. Thank you. All right, so let's get to it. Let's solve this bad boy. So our A value is negative 16. Our B value is 273. This will be a little bit uncomfortable just because we haven't really worked contextually with numbers this large. And this is where having the calculator is a game changer. Trying to do this manually is like one problem would take you like 25 minutes. So again, make sure you have acquired a calculating device. All right, let's do it. So our quadratic formula, remember, is opposite B goes first. So what do we start with? Negative 273 goes first. And then we're going to put our infamous plus or minus sign. The square root of B squared goes first. So on your calculator, type in 273 squared. That is 74,529. Minus 4 blank blank. All over 2 times A, which is negative 32. Good. Do we need to pause there? Is everybody okay? Okay, we're going to, you good? Okay, we're going to fill into the blanks now, of course, A and C. That's the quadratic formula doesn't care what level of math you're doing, what part of the year it is, what context you're using it for. It is what it is. So it won't ever change. So A, I'm going to put negative 16 in the first little parentheses. And then for C, I'm going to put in 150. And you know this because I've asked this question many times over our time together. Is this going to be a minus or a plus inside the square root sign? It'll switch to plus. So again, I can bypass minuses and negatives. It breaks my heart when I see people clumsily working with minuses, and it's just think think first about with clarity the simplicity of math, like I've been doing throughout this lecture. If I see two negatives dividing, why type them in? Like in a case like this, I'm just going to type into my calculator 7,400 or 74,529 plus 64 times 150. And I just did the 4 times 16. You wouldn't have to do that if you didn't want to. But the point I'm trying to make is just, for God's sake, dispense with the negatives. You know they're going to go away, get them gone. And then just type it in because I'm interested in that number. So I'm going to type that in right now. So I'm going to do 7,450. Why do I keep doing that? 70, geez, I must want that number to be smaller. 74,529 plus 64 times 150. Now there's going to be a number just sitting on my calculator screen right now. I'll write it over here. It is 84,129. What do we want to do to that number? What is this number? What does it take the place of? Everything inside the square root, like everything I'm about to place in this large green egg, is about to be replaced with one number, 84,129. So the calculator, any calculator, is only as good as the knowledge of the person using it. Like, do you know where your own buttons are? Which is why it's imperative that you just have one that you know how to use. So I'm interested in that square root. So to do a square root, I know how to do it on mine. On yours, you probably have to hit like second x squared, something like that. You should know how to find a square root on a calculator by the end of your junior year. So we're going to do the square root of 8, 4, 1, 2, 9. Make sure you hit enter. And that is, I got to be honest. I think if I were to round that, because I see this number. I see, oh, that's a terrible color, dude. What are you doing? Let's work harder here. I see 290.0499957. I feel at this point like you and I could safely round this to about 290.05. Because what's going to happen is all those nines are going to bully up together and eventually force that four up to a five anyways. So I think that's probably going to be enough accuracy for us. Any questions so far? Okay. So I'm going to do a little bit of erasing up here on the board. Get rid of some things. I don't need this original thing anymore. I don't need, oh, actually I did. Can I undo that? I don't think. Let me see. No, I can't undo that. So that was my bad. So that's okay. I'll just plug it back in a second. That was stupid. So what we have is this. We have negative 273 plus or minus 290.05, all divided by negative 32. Good, good. All right, so let's take a peek at these, and let's, again, people that are more thoughtful and intelligent perhaps, or who are more relaxed about math, are going to see that one of the answers does not even require our attention. Let me ask you a very basic question. Imagine we traced the plus pathway, this one that I'm circling plus. If you took negative 273 and added 290, what would you get? Positive or negative? You'd get a positive. And what's a positive divided by a negative? So we can omit that answer. We would agree. And you might say, well, why does that? Why do I get a negative? Like, that doesn't seem fair to me that I even could. And the answer to that question is because the rocket got launched from a tower. And so if you drew a picture of the situation, the rocket sits up on a tower like this. So here's like a tower right here, and the rocket's flight can be modeled like this. Pow, and it hits the ground. So one of the answers would be negative because if you went back in time, I'm going to add a little green piece to the rocket's flight right here. Do you see that? That means that the rocket would have been on the ground if you could go back in a time machine. So we don't need to consider that answer. But that visually, I know that's not the best picture you've ever seen, but that's why sometimes you're going to get a negative answer. Okay. It's not just the math gods being cruel. It makes sense in the context of this parabola why one of them would be backwards. So we don't need that one. So the one that we need to type into our calculator is negative 273 minus 290.05, all divided by negative 32. This makes sense because we're all big kids and we understand that the top is going to be a big negative number and a negative divided by a negative is a positive. So obviously this is the one of the two answers that we want. So using your calculator, type in negative 273 minus 290.05. Make sure you hit enter after that. Unless you know how to use parentheses, use enter as your parentheses. We need the calculator to calculate the top before it divides. So with that number on your screen, just hit divided by negative 32, and you get an answer. And it says to the nearest hundredth of a second. I'll give you a second to type that in, but my calculator, I will write it in red, gave me this. Well, you get caught up. 17.595 blah, 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 blah. So in this case, which one is the nearest hundredth of a second? Which one of my decimals is the nearest hundredth of a second? The 9. And what's going to happen to the 9? It's going to go up, right? So it's going to go up to a 0 because the 5 makes it go up to a 10. And the 10 forces a number to bounce to the left. So I would type in 17.60. And I get the question a lot, do I need that 0? And the answer is yes. If someone asks you to round to the nearest hundredth, make sure you have the hundredths place visible, even if it's a 0. So, and if this is wrong, I probably won't go back and redo it because I don't want them running out of time. But the point is, like I said 20 minutes ago, if my answer is not right, but I know I'm doing it right, like I'm vibing with the problem, then I just need to go back and re-examine whenever I rounded a decimal at some point, did I round it too hard? If I did, then I got to go back and give it a little more love. So we'll try this one. So 17.60 seconds. Does that seem reasonable? See, it does, doesn't it? Yeah. So fingers crossed, I guess, huh? So that is that. And I say you might see some other types of problems, but they all are going to come back to one of those three concepts. Either how long does it take something to get back to 0? How long does it take to get to its apex? Or what is the height of the apex? The vast majority of problems involving quadratics are going to be related to those. There is one that is not, I hope, in this assignment that we'll talk about probably Wednesday. I was planning tomorrow, but probably be Wednesday. So why don't we get our Chromebooks out, you guys, and let's see maybe if you could get a problem or two done before the end of class today, and then I'll give you some work time tomorrow for this. Sound good?